Hi Han, welcome to 7th video session of segmentation. Today we are going to cover segmentation by morphological watersheds. Examples 1, 2, 3, use of motion in segmentation, and we will finally go for multiple choice questions. Segmentation by morphological watersheds. The concept of watersheds is based on visualizing an image in 3 dimensions, 2 spatial coordinates versus gray levels. In such a topographic interpretation, we consider 3 types of points. Points belong to a regional minimum, points at which a drop of water would fall with the certainty to a single minimum, points at which water would be equally likely to fall to more than one such minimum. The principal objective of segmentation algorithms based on these concepts is to find the watershed lines. So watershed is useful for segmenting the objects that are touching each other. To understand the watershed transform, we view grayscale images as a topological surfaces where the values of f of x, y corresponds to heights. Water falling on watershed ridge lines separating the two catchment basins would be equally likely to collect into either of two catchment basins. Watershed algorithms then find the catchment basins and then ridge lines in the image. Suppose a hole is punched at each regional local minimum and the entire topography is flooded from below by letting the water rise through the holes at uniform rate. Pixels below the water level at a given time marked as flooded. When we raise the water level incrementally, the flooded regions will grow in size. Eventually, the water will give rise to a level where two flooded regions from separate catchment basins will merge. When this occurs, the algorithm constructs a 1 pixel thick dam that separates the two regions. The flooding continues until the entire image is segmented into separate catchment basins divided by watershed ridge lines. Segmentation, watershed segmentation algorithm. This is the original image, topographical view, C and D, 2 stages of flooding. So this is result of further flooding, beginning of merging of water from two catchment basins. A shared dam was built between them, longer dams, final watershed lines. Segmentation by morphological watersheds. Example, image of blobs, image gradient, watershed lines superimposed on original image. The use of motion segmentation, accumulative difference image. This is ADI's accumulative difference image of a rectangular object moving in southeasterly direction. Absolute ADI, positive, absolute ADI. This is positive ADI. This is negative ADI. Building a statistics reference image. This is A, 2 frames in a sequence. This is eastbound automobile subtracted from A and background restored from the corresponding area in B. MCQs. The concept of watershed is based on visualizing an image in 3 dimensions. True or false? It is true. Software engineering in the morphology process is called SE in the morphology processing is called software engineering. Structure eliminate none of the above. The answer is C, structure eliminate. Reflection of the rectangular SE is always square, translated symmetric, asymmetric. Answer is C, symmetric. Digital function derivatives are defined as addition, division, differences, multiplication. Answer is C, differences. Examples of similarity approach in segmentation are region growing, region splitting, extraction, both A and B. That is region growing and region splitting. Segmentation is a process of low level process, high level process, edge level process, mid level process. The answer is the mid level process. These are the references. Thank you. We'll end the session here.